I hope you can hear me. You cannot see me. If you have trouble hearing me, please leave a note in the chat right now so that I can see whether we can run that without video. It looks like you can hear me. So, good evening, everybody. I wanted to do this face-to-face so that you can also see me. The plan was to record that. We will try to do some recording, at least audio, and we will do just another recording then later without participants to also explain the task. And there will also be an email going out. So for those that are here, it's a great opportunity for you to actually learn directly about the task, and I hope I can at least share my screen. So what is happening tonight? So tonight we're actually going to release the task to those that have received an email, and what we're going to do now is to explain the steps and that you have to take. So what will happen to you is that when you are actually in the system, you will have to go to the task statement. On the task statement, you will then get a button, and that button says Get Task. And on that task, let me try to see whether I can share my screen. It's still not coming up. On that, once you then click on that Get Task, you will get to a survey that you have to fill in. As we have explained in the overview page, this data science challenge is part also of an NSF study that examines how a digital platform like IronHacks can affect or positively affect the productivity of you in solving our challenges. So we would like to learn more about you as we go, what your skill set is, what your motivations are, and so that's why you would have to first fill in that survey and also sign a consent form and also agree to a data sharing agreement, because you have the opportunity to grab really cool data from SafeGraph that we have pre-processed for you. But to make sure that you're in line with the data sharing agreement, we would need you to consent to that. So that's why there is this survey that you have to fill in first. And once you have filled in that survey, what will happen next is you can actually then see the task on the website. And to make sure that you know how that works, I've actually have set that up for you on a dev site, on a development site, so that you know what will happen actually later tonight as we are going to release the task. So let me try now and share. Okay, so you should see my screen now. You see an image here on my desk. Here in my desktop. So what are we going to do? I'm just going now to show you an overview page. It's content-wise the same, the picture is a little bit different, but what will happen is that you'll see things popping up, and you will see here something popping up like tasks, and you'll see something popping up rules. So what I would like to do first now explain you the rules that you would agree to. So these are the rules that guide the challenge. So first of all, the first guideline is it's individual work, and that's also what we want to evaluate, the performance of individuals within a competitive setting. So it's not about submission. Then, as you know, this hack had several submission rounds. In the end, there was a final submission. That's kind of the most important one. To qualify for the prices that I will explain you in a little bit in detail, we ask you to submit at least 2 times. However, you can submit even more, and there are 2 reasons why you should consider that. First of all, it gives you the opportunity to get an evaluation. You get actually then evaluated in almost in real time. You get feedback from your dashboard, and you see how good you are in terms of your model. And the second thing is also that we also, beyond looking at the prediction accuracy of the model, we're also going to look into the effort that you take. So that might also be important for you to consider. Yes, we only require you to submit 2 times throughout the 4 submission phases, but if you do submit more often, that's actually not a bad thing either. It's going to help, but you don't have to. The third rule is, as I just mentioned, we support scientific research, so we, because of that, you adhere to the rule that you actually fill in those surveys. Otherwise, you cannot actually award you with the prize money. So you're not eligible for those. Also, we have a set of libraries and packages used that are the recommended ones. So we kindly ask you to use those, and so unless communicated otherwise, those are the listed ones for this contest. If you, however, want to use another one, you can certainly do so and propose that, and you would just have to make that very clear and transparent to us. As shown in the announcement and the links we have provided, there's really a large number of libraries already pre-installed. If you want to use more other ones, then it's okay. You just have to let us know. You also have to agree to the data usage policy. So the data we've given you are from a company called SafeGraph. SafeGraph does allow us to use that for scientific research, so you're part of that. After the completion, your right to access expires unless you request for the access. So during the hack, you can use it, and you can use it in our workspace. Once the competition is over, you need to actually contact us for further usage. You're not allowed to use them further. We also have an honors code because, in line with Code for America as well, you should speak and explicitly articulate that this is your work that you're submitting, and you're working individually. And if you are inspired by additional works, for example, you use certain libraries or other official documents that it would you have to state that in the submission form. So you have to be transparent and adhere to that code. And in terms of ownership of code, so we are not owning the code that you create for your models. Only us that's issued just with the data. The data relates to SafeGraph. So in the end, we adhere to the idea of open access, and that's why we also use the Creative Commons license so that it is accessible to the wider society for non-commercial purposes. And that's what also is part of the Creative Commons license, or you can also see that here. Okay? We will never use in any ways your solutions for any commercial ways. The only thing we'll be using is for scientific purposes, and that's why we could also then publish it on our website. We don't want to take any other ownership as maybe a company would do. Okay. I would like you to familiarize with those rules and guidelines. They're not bad, they're actually useful, and also think of you as an individual and their benefits. And the next thing that I would like to do, unless there's a question, is to actually go through the task. I try to see whether there is any questions here. I don't see anything at this point, so I'm assuming it's all fine. So this would happen. So basically what would happen at this point, you would have to get the task. What I would do is quickly kind of stop sharing because I don't want you to lead you through the whole survey right now. So let me just disable at this point this task. But that would happen. You get that button, get the task, and afterwards you would have to then fill in a survey. Once you've filled in the survey, you would actually get the task. Okay, so without making you not fill in the survey, this would then maybe distract you at this point. I will just actually show you the task that you will be getting once you have submitted the survey. Second, I'll be there in a minute. Let me just share again. Still no video, not sure what's happening here. So let me go through the task with you. So what is this contest about? So context, as I mentioned, is we have partners, and that's why it also took us a little bit longer to figure this out, that are sitting inside the University of Purdue, that are data providers, and also the government, that the key data scientists. They want to understand the foot traffic at brands located in Indiana. So when I say brands located in Indiana, this is things like Domino's Pizza, this is Starbucks, where people go and visit and spend money, but knowing about that has two implications for those decision makers. On the one hand, if you see that the foot traffic is actually going back to normal, and when I say normal to 2019, you see, oh, it looks like our economic activity is actually going up again is a positive sign. At the same time, it also articulates risk for COVID infection because those places and those brands have closed buildings, and in the closed buildings, adhering to social distancing is much harder, and also there's no fresh air, as indicated by the CDC studies, and the virus spreads much faster. So knowing where people go and where they're crowded, in particular which brands or places are heavily crowded, is very important to know. So that's why they're called, as I say, can we build models that predict that? And predicting the visitor count at key merchants in Indiana. So for that, you would get data that are temporal. So we don't have time to use data. So you get foot traffic at selected brands where customers spend money and put it then for a future date. So those weeks that are not included in the data set. We have the data after today was about a terabyte of data, hundreds of different CSV files, different level of analysis. One was at the day level, one was at the place level, not at the branch, but of missing data, etc. We all cleaned that up for you so that you can actually start working with a smaller and also cleaner data set, and you don't have to do any kind of big merging here. In the end, that data set contains 369 brands in Indiana that have several places of interest. A place of interest is defined here in this case as a place where people can go and spend money, and something like Domino's Pizza has about 100 places in Indiana. Others might have more, others have less. So Macy's might have, for example, much less. So having said that, your data science task would then be to predict the variable sum visit count. And I'm actually going to guide you through the data frame a little bit. We have given you data from week 10 starting week 10 as a starting date, because that was the month when we actually officially had identified COVID cases, and also the executive order to stay at home was released. And you see also have a link here that kind of justifies why we decided to give you that. And as we are now moving through the 4 phases of the challenge, we will actually change the target of the prediction. So why is that? We are actually getting more data all the time from SafeGraph, and then you would also then, your prediction move to the next week. So in the first round of phase, I'm always flipping with these words, until the first submission deadline, you get the data week 10 to week 17, and then you make a target prediction for week 18. And then we add another week 10 to 18, you make the prediction for 19, and so on. So it doesn't mean that your model changes. From this, you just get another data point. So it's not a new modeling, it's just adding more data to that so you can also further verify your model. So once you submit, in case you decide to submit, and we strongly recommend that, so you only have to make 2 submissions, we will actually score your results, and then in your dashboard you see the results. And how we evaluate those, it will be further down in the test. So even if you're not familiar with time series and you might not be scared, that's not a problem. So if you have never heard of a REMA or something like that, it's not a problem. If you've been trained in machine learning, for example, and I know sometimes time series is not necessarily covered in a class like that, you don't have to get scared. Why? If you just visually inspect the data, this is just a bit of a tip, you actually see that there's, sometimes a bit of a linear trend, and you might even try a linear regression. Or you can also just, turn that into a classical supervised learning task where you say, okay, I lag some variables and I use week 10 to 16 to build the model. Let's predict week 17, and then I use that coefficient to make the prediction for week 18. So that's a bit of a hint. Whether you're actually going to use all the different lags, that's also a question. You might achieve just fine with using 16, 15, or 14, just if you just explore a little bit the correlation of the variables, and that might also be quite helpful. Now, everything about the data. As I mentioned, it's data from 369 brands, and that's starting from week 10 to week 17 or week 20. So then based on that, the entries in the table that we were creating for you is basically 369 times here 8 or 9 or 10. So this is then the number of bras that we're having, depending on how many weeks we have. Why? Because it's structured and it clearly time series structure. So each brand has a unique identifier. So this would be the first entry. And once you then actually query this from the BigQuery database, you'll see that also. Then the next thing is there will be a brand name. So for example, Domino's Pizza. Then we have two variables that are not time variant, so they're time invariant. So we give you a 6-digit NICE code. This is based on the official industry classification. That's not, we didn't make that up. That's how a lot of studies that look into industry differences are categorized. We also give you a top category, which is just using the first 4 digits, and then it's actually a string attached to that, like restaurants and other eating places. Here a quick tip for prediction modeling, that might not necessarily be the most important variable you're using because it's not an integer, it's not a continuous variable. However, if you want to later on explore the data and also visualize that, that might be interesting for you to know, is it a restaurant or not. For sure, if you are a machine learning person, you do some feature modeling, you could use that also for feature modeling. It's something to think about depending on what you've done in the past. Then we have the week number. So this is the number of the week, and we say that we say Monday is the start of the week. So following this classification, the first week starts on January 6, 2020. So we wanted to make sure that there's no difficulties in terms of timestamps and different classification of when we start. So this is set to you. You'll also keep the date stored in there just to use a reference so that you actually know, hey, what is actually the start of that week, what's the actual date associated with that, just for your own interest. Then the interesting variables actually start. For each brand, you get the number of POIs. Let me again clarify what's a POI. It's a distinct place of interest associated with the brand. So for example, let's take now Domino's Pizza, and I did this all for Domino's Pizza to explain that. Domino's Pizza has, in week 1, for example, there are 98 places associated with that. Then we have cards per week. So this is the number of unique cards that are served in the sample for this brand in a particular week. Then you have transactions per week. So it's the number of credit card transactions made by customers for this particular brand across the different POIs for that particular week. Then we have total spend per week. It's like so sum of total value of all transactions for this particular week in US dollars. You get that. We did this a float, and it was actually, I rounded it up to 2 digits. Then, now we have some of the pattern data. So the average distance from home is, it's like how the visitors at a Domino's Pizza, what's the average distance what's the place average distance from home across all the visitors? And another one is also the standard deviation at distance from home. Then we also have an average median dwell time. So there's a median dwell time for a particular place, and then across all the different places you get an average of dwell time, and then we also have the standard deviation. And then the last one is the sum visit count. So this is all weekly data. So you have this for each week, which you can use in your model. As I said, you might not need that, depending on how you approach the problem. Okay, there might be a general question also, where does this data come from? I wanted to clarify that also during this introduction. So this data is only for Indiana, and in case that was not clear, for only brands in Indiana. However, this is from a bigger data set from the United States, from a panel of mobile phones, 45 million mobile phones residing in the United States, and in Indiana it was about 1 million mobile phones. So it's not the complete population of all human beings residing in the United States, but it is a representative sample. So there are some studies that show that. So I just wanted to make sure that you know that's a pretty big sample, a pretty representative sample. If you think, we have in India more than 6 million, so it's a really large portion. There's have also the implication that the visitor count that you will be predicting is not 100% the representation of the population. There's a way then to actually normalize that. It's also something we would, in the end, after the contest is over, do with those models that are really well. We can just easily transform it and normalize that so that it represents the actual numbers. But if we didn't want you to worry about that, because it doesn't affect your modeling at all, it's just a transformation later on to account for the actual sampling in a particular area. So the credit cards credit card transaction comes from billions of credit cards reported by Factors, which is a big company that gets information from three sources. One is challenger banks, payroll cards, and government cards. Because of this, it's mostly low-income and younger consumers that you have information about. Again, we have pre-process this data and make sure that you also have a continuous data set, there's no week missing, etc. And so that's also, I think, important for you to know. You don't have to worry so much about that. I hope you find that data set interesting. You might even identify with some of the brands because you go there, or you might have wondered why what the visitor count is. So then an important question also, how do I get access to this data? So you will have a new key in your profile that's now available for those that compete, and you have to follow the instruction in tutorial 2 how to get access to that. It's again in the project called IronHacks COVID-19 data, and in there we will have a data set called competition, and in there you'll find then the table we call predictions and COVID-19. Here's the libraries. I talked about this already. In the essay in the rules section, you were asked to use those. And then the submission requirements, there are multiple submission. However, we'll only open the first upcoming one. Right? So we will go through this. You cannot submit phase 4 at this point. Overall, you have to only submit one. So let's look at the submission requirements. You have some required submission material for all places in case you decide to submit 4 times. You have to submit a CSV file and you have to submit your notebook. And then this file that you will be submitting, the CSV file, should have a prediction for the 369 unique merchants with a unique UID and a specific week number. And it should be structured in that way. So you have an identifier, then column separated week number, and then column separated sum of its accounts. So, and for the first thing, since you're predicting for week 18 in the first submission, then you should have your week 18 and the predicted business accounts for that particular here. That will be UID, it's the identifier. You basically have submit, then one with the 369 cost. You need to save that then with a correct file name that's predefined. Depending on the phase, this will vary, submission phase 1, 2, and so on. In addition, we also ask you then to submit a notebook. And here again, we ask you to use the following naming convention. There will be also some additional information that we ask you to fill in, which is a short description of your model, etc. We also give you voluntary opportunity to submit a visualization. In the final phase to compare to our partners so that you basically visualize the temporal development. I personally think it's the first thing I want to do. I want to explore visually and do some exploratory data modeling before I go into modeling, so you might have that handy anyways. If you want to also then visualize the result in a nice way, show the predictions that you have for the next week, and including also the error term, that's something I think strongly recommend you to do, but it's not required. How do you evaluate you? So the primary evaluation is the prediction accuracy. For that, we're going to use the mean squared prediction error, and you see that formula here. And N here is the number of entries in the prediction set. COVID-19. So this would be it, and this is the formula. We then calculate that for each phase after submission, and then the results will be released. And also a quick note, I forgot to mention that if you have log transformed to data, because account data might be a little bit skewed, then make sure that once you have estimated a prediction to actually be transformed. So you need to use the exponential of it, or to have it shifted by 1 or something. You should do that. in case you decide to do that. It really depends a little bit on the model that you're using. If you're doing your regression, you might want to actually learn transform. Yes, the secondary revelation is your effort. So in addition to that, we also want to recognize if you're taking a lot of effort, and even if your MSP isn't that hard. So we look into a compound of things. So how many submissions have you tried? Did you try to add code that's valuable? Did you try different models? What's your overall activity on the web space? And also, did you try to take the effort to communicate your results in charts? So it's not like doing everything more than what, that's not what we want. It's just we want to see whether you're trying to do something that's value adding. So just submitting empty things definitely not going to help you. So it's really about value adding things and not just pressing hit submit or adding some fake submission. So we'll check whether it's actually value adding. At the same time, we also want to recognize effort that we made by people. So how do we then actually give out the awards and the prize money? So we depending on the prediction accuracy, we will actually give out best solution awards. And the best solution awards will first place, second place, third place, $200, $120, and $80. And the best solution is based on the average MSP of your two best solutions submitted. If you make more than two submissions, we pick the two best. Based on that, we will then rank all the participants and select the top three. It will be awarded following cash prize. Please note that those will also be shared and featured as showcases by us on the website, but also by our partners. So if really get to go there, this in the end will also lead to some need to visualize the results, because that's how we would also then demonstrate on the website with some charts that show it nicely. For sure, it can also help you for getting some improvements for incentives. Also wanted to point out that those that make it to the top three, they will also consider for a fellowship. We'll set up interviews with all three and then select at least one of you as fellows to work on the IronHacks team with future challenges. We are right now planning a range of additional challenges to come up. And then if someone wants to work as a kind of project lead and coordinating with us and even doing some further modeling, that's an opportunity to get involved. And then we also have the improvement spirit incentive. So if you don't make it to the first three, don't worry. There's still some cash prizes, some cash incentives. We recognize your effort here. So what we'll be using is we'll be using your average MSP plus T1 and effort score normalized on a scale from 0 to 1. And we consider all effort from phase 1 until the end. And then based on that, we'll again rank everybody, and then people in above the 75 percentile will get 30, those between 50 and 75 percentile to 20, and then even if you don't make it to the top 50, you will receive US. Okay? Also, please note that every participant who meets the requirements and the rules of this challenge will receive a digital certificate for participation. Will certify the successful completion of IronHacks Data Challenge and list all partners. You can use this as a digital badge for your efforts to battle COVID-19, and will definitely also be an important, valuable add addition to your resume. Yeah. So now I leave it at this point, and I wanted to ask whether there are any further questions. Now I just quickly wanted to also and go to that slide again, remind you of the next step that you have to take. So once you get an email, this will be sent out tonight. You go to the task section and you complete that survey to get the task, and you read the task carefully that I just showed you. Afterwards, go get your BigQuery key, and that is what you get in your profile, and then you start modeling using your workspace, and we strongly recommend that because effort counts from now on. We report your interaction in the workspace. We report how you query BigQuery, whether you're active. We report that, and we also want to make sure we recognize that. And then there's the first submission deadline. It's on Saturday, August 2nd, on August, and at midnight. And a submission will pop up. There will be a submission popping up about 24 hours after we release the task, so that you have the time. They can start making your first submission, and then your final submission is due on Saturday evening. So that's from my end. Stop sharing now, and Hope that there may be some questions.